Now, in general, if you have a composition of two functions, say for instance, m of x is a composition of function e and I, then its derivative is just equal to the derivative of the outer function e times the derivative of the inner function I, provided that both these two exist. Now for this example, we are to use the product rule and chain rule to find the derivative of the function. So if you recall, the derivative of the product, so y product of the first times the second function, the derivative of a function is equal to copy the first times the derivative of the second plus copy the second function times the derivative of the first function. And now let's apply that to the given function here. If you think of u as 2x plus 1, then differentiating this will be y prime is equal to, copy the first, so that is 2x plus 1 cube times the derivative of the second function. So times x minus 5 prime plus, copy the second function, x minus 5 times the derivative of the first function. Now, when you differentiate the first function, you think of the derivative of u cube. So you will think of the derivative of u cube. And the derivative, so we'll just do that later. So we have 2x plus 1 cube prime. Now, applying derivatives, we have 2x plus 1 cube times the derivative of x is 1 and the derivative of negative 5 is 0. So this is times 1 plus, you copy x minus 5 and then you differentiate 2x plus 1 cube. Now, since we let u be equal to 2x plus 1, then this expression here is just equal to u cubed. So that means we're just going to differentiate u cubed with respect to x. And that is equal to 3u squared. So bring down 3 and subtract 1 from the exponent. So it's 3u squared times the derivative of u with respect to x. Now applying it here, we then have 3 times our u, which is 2x plus 1, so 2x plus 1 squared, times the derivative of u, derivative of 2x plus 1, and the derivative of 2x plus 1 is 2. So therefore, the derivative of the function here is given to the expression here. Again, you can input your answer like this, or you can do a little bit of simplification. Now, let's try to simplify this. So simplifying this, we actually have two terms here, and the common factor is 2x plus 1 squared. Quantity. Now, if you factor out 2x plus 1 squared here, you are left with 2x plus 1. Plus, here, when you factor this out, you will be left with 6. So 3 times 2 is 6 times x minus 5. And then you distribute 6 to each term in the parentheses and combine similar terms. So you have 2x plus 1 squared times 2x. So now we don't have much space. This is 6x minus 30. So we have 2x plus 6x, that is equal to 8x, plus 1 plus negative 30, that's negative 29. So this expression here is the derivative of the given function in the simplest form. Now, next example. Let's use product rule to find the derivative of the given function. So using the product rule, we have y prime equal to, copy the first, so that is 3x plus 5 squared times the derivative of the second, the derivative of x plus 1 prime, plus, copy the second, square root of x plus 1 times the derivative of the first function, 3x plus 5 squared prime. Now on this side, let's differentiate the square root of x plus 1. So square root of x plus 1 prime. To differentiate this, let us first write square root of x plus 1 in exponential form. So we will write this as, so we have square root of x plus 1, write this as x plus 1 quantity 1/2. So in effect, we will differentiate x plus 1 quantity 1/2. So we'll differentiate this. Now the derivative of that using chain rule will be 1/2. So you bring down the exponent, and then you have x plus 1 raised to, subtract 1 from the power here, raised to negative 1/2. And then here the derivative of 3x plus 5 squared, the derivative of that using chain rule is equal to 2. So you bring down 2. You have 3x plus 5 raised to 2 minus 1, which is 1, times the derivative of u, which is 3. And then let's go ahead and plug this into the equation here. Now using our results here, the derivative is equal to 3x plus 5 quantity squared times, now the derivative of square root of x plus 1 is equal to this. So you have 1/2 quantity x plus 1 to the negative 1/2 plus, you copy square root of x plus 1 times the derivative of 3x plus 5 squared is equal to this. 2 times 3x plus 5 times 3. Now, you can input your answer like this in your homework. Next example. Use the quotient rule to find the derivative of the given function. Now, if you recall the quotient rule, we have y prime is equal to low d high minus high d low all over low squared. Now using this formula to the expression here, we have low, that's the denominator, 3x plus 1 cube times d high, that's derivative of the numerator, x squared plus 5x prime minus high, x squared plus 5x below times the derivative of 3x plus 1 cube prime. So the whole thing is, you differentiate the whole thing, divided by the square of the denominator, 3x plus 1 quantity cube, and then you square that. Now on this side, let's compute for the derivative of the expression here. So the derivative of x squared plus 5x is equal to, you just differentiate each term. So the derivative of x squared is 2x, and the derivative of 5x is 5. And then next, we take the derivative of quantity 3x plus 1 cube. So the derivative of 3x plus 1 cube is equal to, so this is of the form u cube, and the derivative of u cube is 3u squared times u prime. So that means this is 3 times 3x plus 1 squared times the derivative of u, which is 3. Now let's plug in our results to the expression here. Hence the derivative is equal to 3x plus 1 cube times 2x plus 5 minus, you copy, x squared plus 5x times the derivative of this, which is equal to, you can multiply this to 9 times 3x plus 1 squared all over, and then you square 3x plus 1 cube, that is 3x plus 1 to the 6th, and this is your derivative. Again, you can input your answer like this. Now let's consider the following example. Find the equation of the tangent line to the graph of the function of f at the given point 0, -1. Now to find the equation of the tangent line, we first have to find the slope. Okay, so we are looking for the equation of a line of the form y equals mx plus b. Now let's compute for m first. M is the derivative of the function evaluated at x equals 0. So let's compute first for f prime of x. Now f prime of x is the derivative of the expression here, and this is of the form u cube, where u is equal to 5x minus 1. Now the derivative of u cube is just 3 times u squared. Again, our u is 5x minus 1 squared times the derivative of u, which is 5. So that's our derivative. Then next, we evaluate the derivative at x equals 0. So we then compute f prime at 0, and that will be our slope. This is equal to 3 times 5 times 0 minus 1 squared times 5. Now, 5 times 0 is 0, minus 1 is negative 1, and then you square it. That's equal to 1. So therefore, you have 3 times 1 times 5, and that is equal to 15. So your slope is equal to 15. Therefore, you have y equals 15x plus b. Now, we want to compute for b. We have x here and y. So we will plug in these values of x and y into the equation of the line here. So you have negative 1 equals 15 times 0 plus b. 15 times 0 is 0. So therefore, b is equal to negative 1. And so therefore, the equation of the line is y equals 15x minus 1. B is equal to negative 1. Another example. The cost of producing X bags of dog food is given by the expression here. Find the marginal cost function. When you see the word marginal, that just means derivative. So we're looking for the derivative of the cost function. So that means you're looking for c prime of x. So let's go ahead and differentiate this function. Now, before you differentiate this, it's easier if you would write the square root of 200 plus 25x squared minus x in exponential form. So you write this as 200 minus plus 25x squared minus x raised to 1/2. And then you can differentiate this using the general power rule. So now the derivative of c of x is just equal to, differentiate each term. So derivative of 600 is 0. So you have 0 here, plus the derivative of the expression here. That is the derivative of u to the 1/2. Now, what's the derivative of u to the 1/2? That is just 1/2 u to the 1/2 minus 1, and that's equal to negative 1/2 times the derivative of u, so times u prime. Now let's apply this formula here. You have 1/2 times u, so 200 plus 25x squared minus x raised to negative 1/2 times the derivative of u, so the derivative of the expression here, which is derivative of 200 is 0, and the derivative of 25x squared is 50x. So it's 2 times 25, that's 50, 50x minus the derivative of x, which is 1, so minus 1. And the expression here is the marginal cost function. Okay, so let's try to simplify this a little bit. Again, this one is acceptable, but let's just write it in a simpler form, which is 50 minus x divided by 2 times the square root of 200 plus 25x squared minus x. This is your marginal cost function.